The next thing we're going to do is kind of just a little bit weird. It's just a little bit of an extension beyond what we were doing in the last video. So when you look at these, I mean, especially these first two examples, it's going to be like a cos and an inverse cos, a tan and an inverse tan, a cos and an inverse cos, a sine and an inverse sine, an inverse sine and or an inverse tan and a tan, an inverse cos and a cos. They're going to be undoing each other. It's kind of like squaring and square rooting. And so what most people go is they're like, okay, well, if they undo each other, the answers are root 3 over 2, 2, 1.8, and negative 4.2. And they're like, ah, done. Not the case. When they write these questions, what they're checking is that you aren't just doing that, and that you are checking that the ratio is in the domain of the function. In other words, if we scroll back up here, when we think of domain, sine and cosine, when you're taking an inverse sine or an inverse cosine, you can never put it in of a ratio that's less than -1 or greater than 1. In fact, try it now. It doesn't matter what mode your calculator is in. Just do like inverse cos of 2. Right? Your calculator says error. It can't do it. It can't compute anything outside of -1 to 1 because your graph doesn't go higher than that. Tan, on the other hand, can do whatever it wants, right? You can put the inverse tan of 1,000,000 and it will still give you an answer. So for this first set of question, what they're doing is they're checking to make sure that you are aware of the domain of your function. Now, I will say to you that 2 of these are just fine and 2 of these are wrong. Can you pick out which ones? It's kind of in an obvious order. So with this one, if you think about doing this one, if I took the inverse cos of root 3 over 2, right, that's a positive ratio, so I'm going to be in quadrant 1. The adjacent is root 3. The hypotenuse is 2, so it's my 1, 2, root 3. Yeah, I can evaluate it. It would be pi by 6. And then if I took the cos of pi by 6, it would be adjacent over hypotenuse, so it would be root 3 over 2. It's all good. If I did the inverse tan of 2 and then I took the tan of that, it's fine. 2 is in the domain of the tan function. So maybe let's put the domains over here. So for this one, the domain is -1 to 1. For tan, the domain is -infinity to infinity. So it is true. And if you want to double check, feel free to type this in. So you can do tan of inverse tan of 2 and kind of see what it gives you. It gives you 2, and you could have done the same thing with the radical, but it's harder to see. And then what about these ones? Well, cosine is restricted to -1 and 1, so no, there is no solution. And for this one, sine, we're restricted to -1 to 1, so we have to reject that one as well. If you wanted to write something, you could just say does not exist. Does not compute. Okay, these ones aren't super common in your homework. What's more common is these ones, but I just wanted to start with that idea. For the next one, it's that same idea, where generally if you do inverse tan of tan, inverse cos of cos, the answer would be pi by 6. The answer would be 3 pi by 4. The answer would be 3 pi by 4, and the answer would be 4 pi by 3. But this isn't the case. And I will say to you that how many of these are wrong? 2 are wrong and 2 are right again. Which 2 are right and which 2 are wrong? Well, let's check. For tan, what is the restriction in the range? Well, tan is going to be -pi by 2 to pi by 2. So if I was to do this one fully, if I did the tan of pi by 6, because you can also, you don't have to know these tricks, right? You don't have to actually know the restrictions. You could evaluate it. If I do the tan of pi by 6, it's my 1, 2, root 3 triangle. So the tan of pi by 6 is opposite over hypotenuse, so 1 over root 3, or sorry, opposite over adjacent, or 1 over root 3. I don't need to rationalize it because I'm now taking the inverse tan of 1 over root 3. 1 over root 3 is pi by 6, right? They're kind of silly to do because they just undo each other. But what you're watching out for is the ones that didn't work. Cosine, what's the restricted range? Well, it's 0 to pi. Is 3 pi by 4 in that? Yep, that one's all good. For this one, sine is between -pi by 2 and pi by 2. Is 3 pi by 2 in there? No. So now what we have to figure out is what quadrant would my calculator give you that answer in. Now again, you can use a calculator, but if you're thinking about what this means, 3 pi by 4 is in quadrant 2 with a reference angle of pi by 4. In quadrant 2, sine is positive. Your calculator can only give positive answers in quadrant 1. So what it would do is it would switch it to pi by 4. Now if you want to check this, what I would say is do it not in radians, do it in degrees. So I'm going to put my calculator in degrees. And then I'm going to plug in the inverse sine of the sine of, now 3 pi by 4 is 180 minus 45, which is 135 degrees. And when I plug that in, my calculator outputs 45 degrees because it can't give you 135. There's no way that it can do it. Its brain is programmed to give you an answer between negative pi by 2 and pi by 2. So then lastly, we give you this one, which is the cos. Cos, we know that the restriction is from 0 to pi. And if we look at 4 pi by 3, that's actually in quadrant 3, right? It's 1 pi by 3 past 4 pi by 3. Your calculator can't give you an answer in quadrant 3, so you got to think about what your calculator would give you. In quadrant 3, your cosine would be negative, and so cosine likes to give negative answers in quadrant 2. I should circle what we mean here. So for this one, we had to give it in quadrant 1, and for this one, we had to give it in quadrant 2. So if you have a reference angle of pi by 3, and you want to give an answer in quadrant 2, it would be 3 pi by 3, right, because that's pi, minus pi by 3, which would give you 2 pi by 3. So these ones are kind of out to get you, but you just have to think about your restricted range. So tan can only give you answers between negative pi by 2 and pi by 2, as well as cosine, and then cosine between 0 and pi. These last two questions that you're doing, they're not the ones that undo each other. They're the ones where you actually just have to do all of the work. So the first thing we're going to do is take the inverse tan of negative 1. So if I'm doing the inverse tan of negative 1, if you think about it, in my restricted domain, right, negative 1 is a negative ratio, so it's going to be in quadrant 4. So what angle is that going to be? Well, it's my 1, 1 root 2, which is going to give me pi by 4. Now, your calculator would give you negative pi by 4. So then the question is, what is the sine of negative pi by 4? Well, the sine of negative pi by 4 is going to be opposite over hypotenuse, so negative 1 over root 2, or root 2 over 2 negative, right? Rationalize your denominator. Weird, hey? So, and again, if you want to check this, you can plug all this in your calculator and then just make sure that it gives you this exact value. All right, last one. So for this one, the first thing we're going to do is evaluate the sine of pi by 2. I shouldn't put an equal sign. This is just work. The sine of pi by 2 is 1, right? Because it follows y. So now we are doing the inverse cos of 1, which cos follows x. So to get 1, you're actually going to be here. And so this would be what? Well, cos has to give you an answer between 0 and pi, so we'll call this 0. And again, this would be a nice one to check, actually. You could be in radians or degrees, but you could go inverse cos of the sine. If you're in radians, put pi by 2. If you're in degrees, put 90, and it should give you 0 as an answer. Hopefully you didn't find those videos very too confusing. This has been a bit of a work in progress, and don't feel bad if you find this weird. Come back to, why does my calculator give the answer it gives? Why is it in quadrant 1 versus quadrant whatever, right? And that's what this is all learning, so that we're getting ready for 7.5.